Pre-calc, pre-calc, pre-calc. Watching this on Wednesday, on the 28th, last day of February. The year is speeding by. Alright, tonight I'm not going to present anything new, but just sort of recap some of the topics that we have addressed recently. I was grading some papers not long ago, and I found some mistakes in your graphing of logarithmic functions. So I'm just going to go ahead and review the main points, and I'd like you to either add this to the notes where you were graphing in your comp book or just in a new section. So you can call it graphing review. And I'll remind you, everyone got the basic log graph. All you need is 2 points, and that is when x is 1 and x is 4 for this example. What exponent do I give 4 to get 1? And what exponent do I give 4 to get 4? So 1, 0 is always on a log graph, and this one has 4, 1. The tail goes like that, and then it hits this point and gradually increases. So that's a basic log graph. This one happens to be log to the base 4. Now, what happens when I put y equals negative log 4x? This will reflect across the x-axis. It takes whatever was here, all these different points, and changes the sign of each one. So whatever was positive becomes negative, and whatever was negative becomes positive. So this graph is called the reflection of this graph. So I reflected this around x, and almost everyone reflected this around y, and I would like to know why. Why do we sin? Alright, now we have this case where you do reflect it around y. So this, when the negative sign is inside the argument. And again, the argument is that to which the log is applied. So this is the argument, and the negative is inside of it. It reflects across the y-axis. So we're going to take the original graph and reflect it across the y. So here's the original log shape, and when you go across the y, it ends up over here. Alright, so this is the graph of this. Alright, and the other one that comes up sometimes is this kind of transformation. And we have to recall that when the change is hugging the x, it's inside the argument, it works opposite to what you think. So this stands for, you'd think it would be left, but it's a right. So you want to go right 2. So you take the typical graph and move it right 2. So it crossed here, now it's going to cross here. Alright, so that's a good sketch for this function. And when you take it outside of the argument, see, this argument only has an x in it. So that plus 2 is outside of the argument. I could have write it more clearly as this. These are the two are the same. This clearly shows you the 2 is not inside the argument. So this acts like you would think it does. This is an up 2. So again, up here, if it was a plus 2, it would be to the left. And if it was a minus 2 here, it would be a down. So take the original graph and just move it up 2. I usually take the crossing points and move them, and then just draw the shape around that crossing point. Alright, so I just wanted to remind you that this is a reflection across X, across Y. This is a left, I'm sorry, you would think it was a left, it's a right 2, and this is an up 2. Alright, so those are principles that I'd like to see in your work done correctly. And in the matching, there was a matching section. A lot of those were wrong. So it's putting these principles into play. So if you got most of them wrong, please redo them. Alright. Another thing I want to bring back to mind, and I don't know that a whole lot of us have started these, but it's exponential equations. So I'm a little bit ahead on my videos from your work. So that's why I'm not teaching anything new. We're just kind of reinforcing what you're doing in class. So 6 times the quantity 2 to the 3x minus 1 minus 7 equals 9. Alright, so how do you know this is an exponential equation? Because the unknown is up in an exponent. So we're going to have to get it down. So before we can get it down, we have to get the expression with the exponent by itself. So I'm going to move the 7 over first by addition, and then divide by 6. So that 7 and 9 is 16. 16 divided by 6 can reduce to 8/3. So I'll just do that, 8/3. So now, how do I get the exponent down to where I can solve for it? Well, that's where you've been trained in your video, and we discussed one in class today, which is Monday. You take the log of both sides, but that log should match this number. So the base 2 log is what I'm going to take. Log to the base 2 of 2 to the 3x minus 1 equals log to the base 2 of 8/3. Why did I take log to the base 2? Because it creates an easy peasy problem over here. What exponent did I give 2 to get 2 to the 3x minus 1? It's just 3x minus 1. Now over here, we learned to take logs to other bases on our calculators by calling in a log that we do know. So I'm going to use an LOG, which is a base 10 log. Alright, so we learned how to do that. You can watch that part of the video previously again if you need to. So log to the base 2 of 8/3 over log 2. So I put all that. Now we're solving for x, so you're going to add a 1. So move the 1 over, and whatever this mess is divided by 3 will take care of the 3. So we get x equals this right here. So I tapped all that into my calculator and I got 0.806. And that is the solution. Alright, so in addition to that, I wanted to go over one log equation in case you get to those tomorrow. And you should be, so let's see how they work. Alright, to solve a log equation, we're going to get log in one side once, or we can have it at most once on each side. So here we have 2 logs on the left and none on the right. It's okay to have none, but it's not okay to have 2. We only want 1 or 0 logs. So I'm going to use log rules, and whenever you have 2 logs that are added, you can write it as 1 log with the arguments multiplied. So I'm going to multiply those out, and I'm going to get log to the base 3 of x squared minus 8x equals 2. Now we learned how to, previously in video land, we learned how to undo a log, and we are going to exponentiate each side, and we're always going to use the number according to the base of the log in the problem. So I'm going to make this an exponent of a 3, and I'm going to make this an exponent of a 3. So this is 3 raised to this mess equals 3 squared. So what is log to the base, what is 3 raised to the log of the base 3 of x squared minus 8? It's just x squared minus 8, x squared minus 8x equals 9. Quadratic, so pull it over, pull the 9 over, set it equal to 0. Follow your mathematical nose and hope that it's factorable. And this one is x minus 9, x plus 1. So we solve the 2, go down the 2 branches, x equals 9 when you set that equal to 0, and x equals minus 1 when you set that equal to 0. Then we learn we have to check those. So we have to put the 9 back into here and see if it creates a negative argument. This is 9 is positive, 9 minus 8 is positive. So check. This one's good. How about negative 1? If I put it in here, it creates a negative argument. We cannot use it. Alright, so that's our video for tonight. Just bringing back some of the most recent topics and fine-tuning them so that you'll do well tomorrow. Alright, see you then. Good night.